Hi, everybody. I'm Chris Preimesberger, editor of eWEEK.com. Thank you very much for joining us for this latest segment of eWEEK eSpeaks. It's a series of casual conversations with IT thought leaders from all over the business. Our interviewee today is Patrick Conte, who was with Opsani. And Patrick, what is your role? You are not the CEO there, are you?
No, I'm the Chief Commercial Officer, which is, probably a shorthand way of saying basically all the stuff that touches customers.
There you go. Yeah, thank you. I had wasn't clear on that. I got to get clear ahead of time before we do the interview. Thank you very much for your time today. And tell me a little bit about your background and a little bit about what Opsani does.
Sure. So I'll try to spend a little less time on me and more on Opsani. I've been a Silicon Valley entrepreneur for 20 plus years. Moved my family here from the East Coast back in the late 90s. I've been in, I think this is my 7th startup. I've exited 3. Some of them are pretty good names. One company we exited to NVIDIA. A bunch of my friends are still there, doing very well in the 3D graphics space. Another one we exited to Sun and then became part of Oracle. That was good. That company was called Cobalt Networks. Another one was a Topspin, which we exited to Cisco back in the mid 2000s. And that's actually where I met the founder of Opsani, Ross Shibler. He was the founder and CTO of Topspin. He and I worked together there for almost 5 years with a very, very interesting and successful supercomputer company that was focused around data center virtualization. Really, before we were talking about server virtualization, back in that time, we were talking a lot about virtualizing the data center. So we had this very cool switch product that converged all the fabrics in the data center together. All this stuff pre-cloud, right? We were still a few years before cloud was a word. And then I've been in cybersecurity for most of the last 10 plus years, and also in the Java virtualization space and optimizing Java applications. So I've been sort of around the horn in tech and in data center over the course of the last 20 or so years. So that's a little bit about me, and basically I should say in all those roles, including even when I was the CEO of an early stage cybersecurity company, my role has really been on the go-to-market side. And typically what I've done is found an interesting technology, been brought in, created the go-to-market strategy, and then built the team to execute on the strategy and drive growth. And so that's really the reason why I'm here at Opsani. Ross and I've known each other for a long time now, and Opsani's at a very interesting sort of juncture, if you will. And what Opsani does is we've built a platform that uses AI and machine learning to tune all of the key parameters that basically make up a cloud application. And when I talk about parameters, I'm talking about like infrastructure parameters, not stuff inside the code. Like, we don't touch the code. We're essentially like a black box service that tunes things like CPU, memory, replica counts, can get into the Java stack and tune garbage collection and heap sizes and things in the database. We take all those key parameters, and if you just had 5 or 6 different parameters, the possible combinations of getting to an optimal set of settings is in the trillions. So human beings can't really tune applications anymore, even though there are armies of site reliability engineers in companies that are trying their best. As soon as new code gets pushed, or as soon as the traffic changes or whatever, those applications go out of balance. And that's when you get faults, you get delays, you get unsatisfied customers on the other end of that SaaS service. So what our software does is it does what all the SREs would do if they could possibly do it at machine speed. And so we're constantly adjusting all of those parameters to match the conditions of the software, to match the conditions of the incoming traffic. So if traffic spikes, we soak it up. If traffic drops, we adjust the size of the infrastructure needed. So what happens and what the result of all this is, Chris, is that the customer gets the best performance for that application that he's going to get. We guarantee that he can get the best performance. The second thing is he always gets the best cloud spend for that application. And that comes from right sizing the infrastructure underneath it, all the things I mentioned, the replica counts and CPU memory, et cetera. So he's always got right sized infrastructure, even if the traffic is spiked or if it's dropped, right? We can adjust no matter what's happening. We do it so fast that we are always keeping the customer, the end customer's experience at a nice steady level, at the service level objective that our customer sets for his application, so that his end users have a satisfying experience. So essentially, the three things we solve for are performance, cost, and reliability and stability of the application. And the only way to do this and to keep this thing in balance is with machine learning. So that's what we do. And we do it autonomously, we do it continuously, and we do it at scale, which means we can go from one application up to thousands of applications using the same backend, the same engine.
Wow, that's a lot. And boy, is this, Patrick, do you consider this an observability type tool? I think it kind of fits into that category, doesn't it?
Certainly, observability is a piece of it. But there's one really interesting thing about our product. Customers can choose to, once we've reached an optimal set of settings, they can choose to allow us to auto promote that into production. And so, as you're rightly alluding to, customers don't want to, just turn you loose on their applications, right? What they want to do is they want to see how you're going to adjust those things. They want to see how you prove yourself. So what we actually do is we put, I don't want to get too wonky, but we basically put a tuning instance into their application that takes all the traffic that the regular application takes, but is not in production. And so we tune that tuning instance using our machine learning. And once we've reached optimal, the customer sees we've reached optimal. Then he has the choice. He can press a button on our console and promote that to production, or he can click a checkbox and allow us to auto promote. So typically, what happens is our customers wait and see until they trust us, right? They see us go through and do this. They see the SRE we're doing what they would be doing. They see that we can adjust when traffic changes and all these different things happen. And for the first while, they'll press the promote button themselves. But after a while, especially if they have tens of applications, which probably means hundreds of services that make up those apps, they don't have time to watch every single one of those, and every single one of those has to be optimized. So they want us to auto promote at that point in time. So observability, yes, but autonomous is where we really want to help customers get to.
Yeah, boy, yeah, I can totally understand that these systems are getting more and more complicated all the time. Humans cannot keep up with this stuff, so I definitely get that. I guess would this be synonymous to something like, a singer's got a voice synthesizer that helps keep the voice right on track automatically? I mean, that's kind of what I think of, and I think of that's a very simplistic view, but it's kind of what I think of when I think of what you guys do. Isn't that it?
Yeah, that's probably, I would say that would be part of the analogy. Maybe the other part of the analogy would be when that singer, when that soprano reached her, crescendo of her voice and all the glass would crack or whatever. Maybe the AI would just back it off just a few decibels or whatever, so that all the windows wouldn't shatter, right? And and maybe if she were doing scat like a jazz singer, you can't tell when she's going to hit one of those notes. But our product would actually, we would use an auto scaler, which we use. We have our own auto scaler we've built for this for software, but we'd use our own auto scaler to sort of carry the application up and make sure that it still stayed within the ranges so that it didn't break, right? So,
yeah. Okay.
So it's actually a really interesting analogy. I like that.
Okay, cool. Well, as long as we can.
I'm going to steal that, Chris.
That's okay. No, pictures tell a lot. If you can describe a picture of something, people can help understand it a little better. Tell me about the as a service aspect of Opsani. This is a SaaS service, but is it also software that could be used on a private server in a private cloud data center, like for example, a regulated industry type company, something like that?
Sure. So the back end of our product is a service. It's a cloud service, but we've got a front end instance we call Servo that can go into any cloud environment, private cloud, or it could be any of the public clouds. We're cloud agnostic in that regard. And what that Servo does is a very small container instance, and what it does is it acts as a go-between between the application and our back end. So it collects metrics off of however that organization collects application metrics, an APM or Prometheus or an Envoy sidecar, however they get the metrics about what's happening with the application. So we collect those metrics, we send them to the back end, all the magic happens in the cloud back end, and then it sends to this Servo recommendations on what to change in the settings of the application itself. And so, it could be any of those things, CPU or memory or replica count or any of those things. And what happens is then we start making changes to a tuning instance that we put right next to all of the rest of the other parts of that application. So that tuning instance is a replica. It looks just like every other part of the application, but it's not in production. And so we do all of our tuning on that instance. And what happens then is, the back end is suggesting all these changes essentially at machine speed, but it looks to the customer like everything's being done essentially simultaneously. But in fact, it's being done one at a time. But the iterations are at machine speed. Mm-hmm. So that Servo and that tuning instance couldn't go into any cloud environment. And one of the things that I think would be it's important to mention is our customers have been leading us in a particular direction over the last 2 to 3 quarters, and away from legacy environments like VM or even bare metal, which we have optimized before. And they've been leading us to the way that they're building applications today, much more modern tools such as containerization. And in particular, what they want is a way that they can run their applications across clouds. So they want something multi-cloud. And what that means right now is Kubernetes. So most of our engagements right now are around Kubernetes. So as long as the Kubernetes service or platform is running in one of the cloud vendors or is running in that private cloud, we can plug Servo into it and we can do all the optimizations that we would need to. Now, a customer were in a true private cloud environment that might be air-gapped, like a government agency or something like that. What we would need to do would be we would need to take our back end and we would need to put it into whatever cloud they can attach to, such as an AWS Gov Cloud or maybe one of the intelligence clouds. So we could take that and we could put it into, or it could be Azure. We could put our back end there, and then the Servo would just go into the application area. So it would look exactly the same. So we could go into an air-gapped environment like that.
Yeah, so there's a lot of versatility involved in the deployment of this, which is what you need to do at a high volume, especially like that. And I guess lastly, Patrick, as our time is just about up, can you name any of the customers that are buying you right now, or is that something that you keep private?
Sure. We keep most of them private until such time as the customers are okay with us not making it private. But some of our key customers that I think are important to note are Intuit. QuickBooks Online, for example, has been optimized and has shown a 70% drop in cloud spend and a 10% increase in performance. So simultaneously, you get about an 80% price performance to cost benefit. We do a lot of work with Adobe. We're optimizing literally thousands of services for them. And then Ancestry.com is also a key customer of ours. So those are 3 customers that I can mention.
Yeah, well, thank you for that. Appreciate it. And that helps helps our readers identify with you and identify the customers that you're serving. it just seems like you're taking the friction out of all this stuff and you're making it all fast. And that's what IT is all about.
Yeah, I think what we're trying to do here, Chris, just to sort of, wrap things up or maybe some takeaways is, there are a lot of things in the spectrum of optimization. You can start with the APMs, and everybody's got those, but those just tell you, they're important, but they tell you the structure of the application. They can tell you if ports are down or if traffic is not moving in the way that it should, or there's a lot of things they can do with the app, but they can't remediate anything, right? And then in the middle of this spectrum would be, I would call them, older optimizers, other kinds of products that have been out on the market that essentially what they do is they may be using AI or they may be using some type of big data. And what they do is they provide you with a recommendation. And so they spit out a manifest of changes that need to be made to all these different parameters. And then you hand that to your SREs, and then they have to go and put it into effect. But because the CI/CD world moves so fast, new code is being pushed all the time. So probably by the time you put those things into effect, something's changed. The traffic has changed, or new code's been put into effect, or some of the fault condition may have come into play. So the difference is we're autonomous, as I explained before, and customers don't have to touch us once they put us in. Second thing is we're continuous. So we're always measuring and adjusting, creating a new optimal based on the realities of what's going on with the application. And the third thing I think I might have mentioned is we're also at scale. So we can go from optimizing one or two very large applications all the way to optimizing literally thousands of services with the same backend, the same engine. So those three things, continuous, autonomous, and at scale, are the things that make us different from everybody else that's in the optimization space.
Got it. Okay, Patrick Conte, Chief Commercial Officer of Opsani, which is based in Redwood City, California. And you're not in Redwood City, but you are in San Francisco. Can you point us to where you live? I think it's in the picture.
Yeah, so let me make sure. Yeah. So I like this picture a lot. Let me see. I got to get the right finger
there you go.
because it's reflecting. So right about here, about here, the Pacific Heights. That's where I'm speaking to you from, the petri dish of COVID.
You've got a nice view of the bridge from there, I'm sure. That's great. Yeah. Patrick, thank you very, very much for your time on eSpeaks today.
Very great to meet you, and I hope we can do it again sometime.
Oh, I think we will. I think there's other questions I want to go deeper with on you, so we'll do that. All right, for everybody following along to the end here, thank you very much for joining us. Have a great rest of your eWEEK. Thanks for joining us on eWEEK eSpeaks. Go to eWEEK.com to hear more conversations with IT thought leaders.